So in this first video, we're going to take a quick look at how you actually define vectors within MATLAB. So remember that we define vectors within the linear algebra module of the first lecture of the course as just a one-dimensional matrix. So if a matrix is a structured collection in rows and columns of typically numbers, which we refer to as scalars, then a vector is just going to be a single row or a single column. So if we look at this vector that you're going to be defining in your workspace and giving me a screenshot below, we'll notice that it is defined. Well, first and foremost, we know it is a vector because these elements of the vector, elements are just fancy words for the numbers, are enclosed by square brackets. And within these square brackets, we see 1, 2, 3, 4. And the way that this is written, it's written as a horizontal concatenation. So it is a row vector. If matrices are in general m rows by n columns, then anything that has only one row will in general be 1 by n. However, in this case, since there are 1, 2, 3, 4 elements, this is a 1 by 4 row vector. So how do you actually define vectors within MATLAB? Well, the first thing when you're going to define a vector is to pick a valid variable name. And not only should it necessarily be valid, but probably it should have some meaning corresponding to, and this is kind of transitioning to the idea of programming, to the actual quantity that you're describing. So what do I mean by that? Well, first and foremost, there's a syntax rule for defining variable names within MATLAB. They can only contain letters, numbers, and underscores. And in addition, they have to start with a letter. So something like A would be a valid variable name. A2 would be a valid variable name as well. I could add an underscore if I wanted, and that is a valid variable name. But it's probably likely, if you look at this me making up random characters on the keyboard, that it won't be a good variable name. So that satisfies the syntax rules of defining a variable name within MATLAB. However, it's probably not a good variable name because it's not meaningful. But we're not going to worry about that right now. I just want to kind of keep those concepts into your head. And let's talk about how we actually define a variable within MATLAB. So you have to define W, but I'm going to define V. I think that's at least what it is. Let me go back and see. Yeah, that's good. You have to define W. I will define V. So let me define a row vector. Well, in MATLAB, the first thing you do to actually create a variable is pick a valid name, so something like V. And then what we're going to do is use the equal operator. And whenever you see an equal operator, a single equal operator within a programming language, you want to interpret that as an assignment operator. And what it's doing is it's going to take the quantity on the right, and it's actually going to put it in the variable that's named according to the name that we have on the left. So of course, I could just define a variable as a single scalar value, something like V equals 4. And I could omit a semicolon and hit enter within the command window in order to execute that. And keep an eye down here on the workspace. You'll notice that once I execute that command, I see evidence of that variable defined in the lower left-hand corner. Its name is V. It's storing a value of 4. It is by definition a scalar, so it is of 1 by 1 size when viewed from a vector terminology, and it is of class double, and we're going to dig into that a little bit later on. Now, what if I said, oh, I didn't want to define V that way? Well, I can use the clear command, which is a built-in MATLAB function, and if you notice as you type clear, it starts to autocomplete with some suggestive text. It says maybe if you put the name of a variable, I could eliminate that from your workspace. So I will type the name of the variable we just defined, V, and notice that leaves my workspace. Maybe you want to clear your command window. You don't like all of that information there in front of you. The way that you clear the command window is the command CLC. And if you execute that, all of those commands will not be visible to you. Now, of course, they didn't go away. In fact, if you hit the up arrow, notice that you can cycle through all of your recent command history and if you were interested in re-executing something. So we've talked about how to, when you define a variable, you have a valid variable name. It has to satisfy syntax rules. Eventually, it should be meaningful. We use the assignment operator, which is the equal sign. And whatever is in the right side will be abstractly assigned to that variable name that is on the left. And we did it for a scalar. We showed how that appeared in the workspace, how you could clear that variable out of the workspace, and how you could clear your command window. So now let's talk about how you actually define something like a vector within MATLAB. So I'm going to define a 1 by 3. Remember, 1 row by 3 columns means that it is a row vector element of then I'm going to call that variable V, and I'm just going to pick random numbers for the entries. The way that you tell MATLAB that you're going to define a vector, and this is common across a lot of programming languages, is you lead the definition with an open square bracket. And then what you want to do is type your elements. However, you always have to be careful, whether you're in any type of programming language, but particularly in MATLAB, of what characters you use to actually separate the elements. And that is often referred to as your delimiting characters, because that will actually tell MATLAB how you want to structure those elements within, in this case, your vector. So if I type 1, 2, 3, and I close the vector by closing the square bracket, and I omit a semicolon and hit enter, I will have that echoed back to me on the actual command line. Now, I don't necessarily need that because I can see it down in the workspace. But what did I show you there? I showed you if you wanted to define a row vector, you can do it by picking a valid variable name, using the assignment operator, opening with square brackets, entering the elements of your vector separated by commas. Now, what would happen if you re-execute that? And let's actually think about this, and replace the commas by semicolons. So the delimiters have just changed from commas to semicolons. And if you look, and you might first of all ask, well, why are you using the same variable name? Well, I'm allowed to overwrite variable names. If I actually did that incorrectly and I want v to, rather than being a row vector, be a column vector, what you're going to see here is you can just change the delimiters from commas to semicolons and actually make that happen. So notice in this case, you get a 1 by 3, and this would be a column vector. So the key point there is when you define vectors in MATLAB, open and close with square brackets, put the elements within the square brackets, and depending on the delimiters you use, that will determine whether it's a row vector, delimiters are commas, or whether it's a column vector, in which case the delimiters are semicolons. So what I want you to actually do here is just take a snippet. Don't give me an entire screenshot, but a snippet of your definition of the row vector here, and don't use a semicolon at the end, and show me that your vector is correctly defined within MATLAB. And just making sure, I take that back. I asked you to show me that it was defined in the workspace. So what I really want a screenshot of this is a little screenshot of this area down here snipped, but yours won't say v equals 1, 2, 3. You need to put whatever syntax is required in order to define this variable w into your command window and give me the screenshot right there. So let's look a little bit at question 2. We're told that note within your screenshot above, the class variable should be defined as double within the workspace. So we really haven't talked too much about this idea of data types within programming languages, but it turns out that they are incredibly important and they kind of differentiate all of the modern programming languages, what data types are available to you. So fundamentally, data type is nothing more than the type of information that can be stored by that programming language. So there's some very simplistic kind of primitive data types that exist across all programming languages, and then there's some more complex data types that one could use if you're going to be working with particular types of information. And it's not necessarily like the data type that's important. What you'll see as you move on to more advanced programming languages that have this concept of object-oriented programming is often those data types have particular operations that are defined on them. But that's we don't need to worry about that for now. All that we need to worry about is that a data type describes what type of information is within the actual variable. Remember that a variable consists of two things, the abstract name and the physical location in memory. And that physical location in memory is totally abstract. I can't look in my RAM and see the actual address of where this V is stored. I just know that wherever it's stored, it's within the kind of working memory of my program. And here is its size in terms of a matrix. But the question is, how much space is it actually taking up? Well, that's another thing that a actual a variable type or a data type allows you to determine. Now, in MATLAB, that information is actually defined under the term class. And class is kind of like a term that kind of comes out of object-oriented programming, but just know that the data type of each individual element within this array is a double. So that's what I'm particularly talking about in that question. When I say in the data type, in the workspace rather, the class of that variable is defined as a double. And what I want you to do here is to click on this hyperlink and tell me the actual number of the IEEE standard that defines the storage protocol for this data type. So here's what that is actually talking about. It's referring to how you use binary information, because remember back to the first lecture that a computer stores all of its information in binary, a bunch of ones and zeros, how you actually encode those ones and zeros in order to map to the value that you're storing. So let's just click on this real quick just to make sure everyone gets the right answer for this. My organization prohibits that. I'm not overly surprised, but let me go to a new tab here and type it in. And what you will see here is MATLAB represents floating point numbers in either double precision or single precision format. So what we're referring to here when we see double is actually a double precision floating point number. A floating point number is nothing more than a number with a decimal on it. Now you should see, if you Control F or just use your eyes here, there is the actual number or name of the IEEE standard by which that binary value is encoded in order to represent the double. So if you think back to the first homework in the first lecture that you did, we talked about what really was an unsigned integer coding convention, where you took the binary number, like for example 101, and you interpreted each bit as a power of 2. The least significant bit, the bit all the way to the right, was worth 1. Then the next bit to the left was worth 2. Next bit to the left was worth 4, and so on. However, that unsigned binary encoding protocol, it only uses the bits to assign value to the number. What you see here is if you read down in this IEEE standard, they're going to have 63 bits. That's the physical space in memory that's reserved in order to store a double precision variable. And you notice that 63rd bit, which is going to be the bit all the way to the left. And actually, I misspoke a little bit there. Sorry about that. I should say 64 bits because it goes all the way from 0 to 63. I should have caught myself when that came out of my mouth, because traditionally, you know that the storage space that's assigned to variables is always going to be powers of 2. That's how I should have caught when I was saying 63. But from 0 to 63 is 64 total bits. Notice that the 63rd bit, which is all the way to the left, is used to denote the sign of the number. If that is 0, that means that that number is positive. If that is 1, that means that number is negative. What I'm basically telling you here is if you were to look at all the ones and zeros that encode a variable that's stored as a double precision floating point number, you couldn't do that binary to decimal conversion that we did in homework 1, because the bits don't mean the same thing. So that's why when I actually did the lecture on this concept, I was talking about that really that 2 to the n, if you have an n-bit binary number, raising 2 to the nth power doesn't tell you the biggest number that you can store in that particular number of bits. However, it tells you the total number of different things you can encode. So in this, if you got 64 bits, you can still encode 2 to the 64th different things, but what those things mean depends on your actual encoding scheme. So here in the IEEE standard that we're talking about, the bit all the way to the left is reserved for a signed bit. It's kind of like you're writing a plus or a minus in that case. So hopefully that allows you to answer question 2 here. You have the IEEE standard number. Question 3 for the IEEE standard, double precision, defined above. So what I'm looking for here is not double precision. In 2, I'm actually looking for the number of the standard. So hopefully everyone saw that, or you can just click back on the link. But for the IEEE standard defined above, how many bits are used to store this data type? I gave you that answer already. Be careful because it's 0 referenced. It starts at 0 and it goes up from there. So make sure, remember if you have from bit 0 to 7, if you actually count that out, there's 8 bits. So for this word length is a fancy way to say number of bits. How many different values can be encoded here? Well, think about it like this. If you have 1 bit, you can encode either 0 or 1. There's 2 different things that you can encode. If you have 2 bits, you can encode 00, 01, 10, and 11. There's 4 different things you can encode. Really, a better way to say that is there's 4 different codes that can be generated from 2 bits. So in that case, the pattern that we're seeing is if you have n bits, you can generate 2 to the n different amount of encodings. And what you choose to assign to those encodings is really up to you. So the answer that you're looking for the last part of this is that 2 to the n type answer. So take the number of bits in that IEEE double precision standard that we looked at previously, and then just use that as the exponent to that number of bits in order to determine how many different values you can encode. And as a little bit of a hint there, this should be a really, really big number. And that's nothing more than the way that exponential growth works. If you pick, for example, how many different codes can I generate with 4 bits? Well, 2 to the 4th is 16. How many with 5 bits? 32. So it seems like it's growing really slow, right? But even if you go up to 2 to the 10th, right? 1024, pretty big number. So you had 2 actual bytes or 16 bits. You can encode 65,536. So you see, because of that exponential growth, when you get all the way to the word length of the IEEE double precision standard, this is going to be a very large number. So going here, question 4, in the IEEE standard defined above, double precision, how is a negative value differentiated from a positive value? We talked about that. You use the most significant bit all the way to the left in order to indicate whether the value is negative or positive. And that is called using the most significant bit as a sign bit, which is a pretty common way that negative numbers can be encoded within computer architecture. So in this video, I'm kind of telling you what's going on now. I demonstrated how to compute the transpose of a vector using the apostrophe operator. Well, I guess I should show you that. Well, think about what the actual transpose means. When you're dealing with a vector, a transpose is going to take a row vector and make it a column vector, or it's going to take a column vector and make it a row vector. Well, within my workspace, what do I have defined? Well, notice I have the variable that I defined v, and I didn't define another variable, right? But if you look, you can see that there's another variable defined, ans, and whenever you use MATLAB just as a calculator, it's going to take that last result of your calculation and store it for you in a variable called answer. So even if you don't define a variable to store your last value that you computed, it will be available to you. However, I do have v available, which is a 3x1, which is a row vector. So if I click v here, notice, 3x1 is a column vector, I should say, and the apostrophe operator. What do I mean by that? Well, if I take a actual vector and I place an apostrophe after it, and I execute that command, notice that what was an actual column vector has now become a row vector. And where is that stored? Well, since I didn't define a new name for it, it is in a variable called answer here, and that is a 1 row by 3 column variable there. Now, the one thing I wanted to say that I haven't said yet is how you could actually not make this information echo to the command window. And within the MATLAB programming language, the way that you do that is by using a semicolon after the fact. So if you place a semicolon afterwards, you'll notice that the value of the answer variable didn't change. However, when I executed that command the second time, I didn't see the answer echo to me on the command window. So again, what the semicolon does there is just suppress the output from the command window when a command is entered. And that'll be really important as we start to look at scripts a little bit later on. So let's review a little bit what particularly we talked about this. We talked about how to clear the command window. Remember that command is CLC. We talked about how to take variables that are stored in memory down here in the workspace and how to get rid of them. Remember that the way you do that is to type clear. Now you can enter a particular variable name and you can clear the variables individually, but if you want to clear everything, just type clear and use the keyword all. And notice that within this workspace, when I do that, everything is going to go away. All there. I said that if I want to clear the command window and it looks like I didn't type anything in, if I hit the up arrow, I can see previous commands that I've entered. In addition, we talked about how to define a vector, pick a valid variable name, something that starts with a letter and includes only letters, numbers, and underscores. And then after that, I'll use an open square bracket to tell MATLAB, hey, this is going to be a vector, and then enter your elements, which are scalars, in the traditional linear algebra vector case, either separated by commas or separated by semicolons. If you separate them by commas, you're going to get a row vector. If you separate them by semicolons, you're going to get a column vector. And of course, if you have a row or column vector and you take its transpose, which you can do by using the semicolon, that will give you, and it will make a row vector a column vector and vice versa. So V now is a column vector. If I take the transpose, I maybe can call it vtrans, and I assign that new variable, the name vtran, as vtranspose. Notice that, of course, it will be 1 by 3, where v was 3 by 1. And the last thing we talked about is if you don't want the command to echo to the command window, which isn't that important when you're kind of executing or using MATLAB as a calculator, but will be more important as we actually move to taking sets of commands and writing them in a script file and then executing the script. The way that you do that is by terminating your expression with a semicolon before you execute it. So what I'm going to do, actually, even though you saw that it didn't have the questions at the bottom originally, I'm going to add some additional questions to the lab there, just kind of asking you to write a sentence telling me what some of these different operations do. So that's the first video that I wanted to record for our Lab 1, Intro to Vectors and Matrices, and I will see you all in the second video. Remember that this you'll have multiple videos for each part.